section 8.2. First of all, there's a little warm-up for the exercises. Please hit pause on the recording and go ahead and work on these 10 questions. If you don't answer the challenge question, that's okay. We'll talk about that when I return. All right, now go ahead and check your answers to these. Again, press pause. All right, hopefully you did well on those. If you don't, we can answer those questions when I return to class on Thursday. Here are your homework answers. Please press pause and check numbers 8 through 20. Okay, now here are the answers to the rest of the homework. Again, press pause. Okay, hopefully looking at the answers, you can go back through and check your work and see if you made mistakes, if you can find your mistakes. If not, you may ask those questions when I return to class, or you can ask the substitute if she can answer those for you. Moving on, we're going to start today's lesson. Today's lesson is section 8.2, dealing with linear equations in two variables. All right, now an equation, we dealt with equations in the last chapter. Those are obviously statements that have an equal sign in them. When we have an equation in two variables, we're going to be dealing with those types of equations that might have an x and a y in there, two different variables. An example shown on the board, 2x minus y equals 5. Now, a solution to an equation with two variables obviously has to have an answer for x and y. We write those as an ordered pair, x, y, inside parentheses and separated by a comma. Those are coordinates for a solution. Now, an xy solution would be an x and a y value that, when plugged into this equation, give us a true statement. Let's look at a sample question. Tell whether the ordered pair is a solution to 2x minus y equals 5. Well, in order to be a solution, that means that when I plug in an x value, in this first case a, my x value would be 1, and a y value is my second letter in an ordered pair. Again, it's always listed at x first, y second. If I plug these numbers into the equation, will it give me a true statement? So if I take 1 and I plug it in the place of the x, and I take negative 3 and I plug it in place of the y, let's write out what we end up with. So just rewriting that equation, 2x minus y equals 5. Notice I'm going to rewrite the equation exactly as it was written, but I'm going to leave parentheses there for where I'm going to plug in my numbers. So the x value I'm going to plug in right here, 2 times x becomes 2 times 1. Minus y becomes minus a negative 3. And be careful, it's minus a negative. There are two minus signs there. And what we've learned earlier on this year is minus a negative means the same thing as plus a positive. So now when we go ahead to solve this, we have 2 times 1, which is 2. Minus a negative becomes plus a positive 3. Does that equal 5? Hopefully we know that 2 plus 3 equals 5. So yes, we would say that 1, negative 3 is a solution. Again, it's a solution because when we plug in those values, it gives us a true statement. Question B, let's try the same thing, only this time instead of plugging in 1, negative 3, we're going to plug in 4 for x and 7 for y. So when I rewrite this equation, it becomes 2 times x becomes 2 times 4, minus y becomes minus 7. Does that equal 5? And a lot of times I'll put a question mark above that equal sign if I'm checking to see whether it's equal. But when I simplify this, 2 times 4 is 8. 8 minus 7. Does that equal 5? Well, 8 minus 7 is 1. 1 does not equal 5. So we would say then that 4, 7 is not a solution. So again, if you're asked to tell whether an ordered pair is a solution, it just means to plug those values in for x and for y and see if you get a true statement. Now be careful. Sometimes in the equation, it's not always going to be written with x first and y second. Make sure that you're always plugging the variable in for the correct, or the number in for the correct variable. Your first number in any ordered pair is always x, whether x shows up first in the equation or not. So be careful of that. Here are some sample questions for you to try right now. Please press pause, and I will give you the answers. Alright, quickly going through this. If I plug in 0 for x and 4 for y, that becomes 3 times 0 plus 2 times 4. Does that equal negative 8? Well, 0 plus 8 does not equal negative 8. 8 is not the same thing as negative 8, so that is not a solution. For the second one, when I plug in negative 2, 1, that becomes 3 times negative 2 plus 2 times negative 1. Does that equal negative 8? Well, that's negative 6 plus negative 2. Negative 6 plus negative 2 is negative 8. So yes, we would say that 2, negative 1 is a solution. Oops, stay there. Question number 3. Plugging in 4, negative 12. Well, that's going to become 3 times 4 plus 2 times negative 12. Does that equal negative 8? Well, that's 12 plus negative 24. And 12 plus negative 24 is negative 12. Negative 12 does not equal negative 8. So that is not a solution. And the last one, 10, negative 19, I'm going to do down here at the bottom. 3 times 10 plus 2 times negative 19. Does that equal negative 8? Well, that becomes 30 plus negative 38, and that is negative 8. So yes, that one is a solution as well. So for these examples, 2, negative 1, and 10, negative 19 were solutions. The other two were not. Not every equation is going to be given with an x and a y. There might be other variables used. And we may be looking at a real-world situation like this equation here. It says for the 1859 Mauna Loa eruption described in the book on page 407, the lava's distance, d, in miles from the ocean, t hours after it left the volcano, can be approximated by this equation. D equals 32 minus 4t. Well, we can evaluate this equation by plugging in different times. How far would it be after 1 hour? How far would it be after 2 hours? How far would it be after 3 hours? And we can evaluate this to see what that distance traveled was over a length of time. The way we're going to do that is by making a table of values. And sometimes you'll see table of values written like this. Sometimes you'll see table of values written like this. But in each case, we're not working with x and y in this case. We are always going to use our first number is going to be the number that we're going to plug in. It's what we call our independent variable. And the second number is the result we get when we plug that number in. That's called our dependent variable. In this case, we're not working with x's and y's. We're working with d and t. And in most situations, when you're dealing with an equation that has time involved, in this case, t hours, t is usually going to be the number that we're going to plug in. And the answer we're going to get out is a d, in this case, time and distance. And we can plug in 0 for time, and 1, and 2, and 3, so on. When I plug in for t, in this case, d is going to equal 32 minus 4t. Well, we're going to be plugging in a bunch of different numbers for t, And I'm going to use a vertical alignment because for me that's what I'm used to using. And I'm actually, going to extend this table out a little bit more. D is equal to 32 minus 4t. I'm going to write my equation right in there. Now when I plug in a number for t, I can rework this equation right here. D is going to equal 32 minus 4 times t, well 4 times 0 is 0. So D equals 32. When I plug in 1, I'm going to get D equals 32 minus 4 times 1, which is 4, and 32 minus 4 is 28. If I plug in 2, I'm going to get D equals 32 minus 4 times 2 is 8, so 24. And if I plug in 3, I'm going to get D equals 32 minus 4 times 3, which is 12, so 20. And we can continue this on and on and on and on and on. So there's a table of values. Notice what I have is a t that I plug in and a d that I get as an answer when I plug that number in. We're going to write that as an ordered pair, t comma d in this case, instead of xy. And td, my t value was 0, which caused my d value to be 32. So that gives us an ordered pair 0, 32. And 1, 28. And 2, 24. And 3, 20. And this pattern could continue on and on and on. Part B of this question says, how long did it take for the lava to reach the ocean? Well, notice what happens to our d values here. Every time I increase t by 1, my d value decreases by 4. Well, how many times am I going to have to decrease by 4 to get 32 all the way down to when it reaches the ocean? Well, reaching the ocean would be 0 miles away from the ocean. So we want to find out when is this thing going to decrease all the way down and give us a value of 0. Well, if we do the math in our head, 32 going down 4 times, it's going to have to go down 8 different hours. After 8 hours, it would decrease by 32. So the answer to this would be 8 hours. Well, we just made a table of values, which generated a bunch of ordered pairs for us. What we can now do with those ordered pairs is to graph those. We've already done some plotting of points earlier in this year and some graphing. When we graph an equation in 2 variables, what we're going to do is graph all of the solutions to that equation. In other words, all of those ordered pairs that would make it work. If that graph ends up being a straight line, then what we have is a linear equation. So let's take a look at an equation. We're asked to graph y equals 2x minus 1. The first step for graphing any of these lines is to make a table of values. When we make a table of values, we're going to plug in a bunch of different numbers for x. And when we plug those in, we're going to get results of y. And when we plug those in, I'm asking you right now, you're going to find 4 or 5 different points. I want you to plug in a couple of negative numbers, 0, and a couple of positive numbers. In this case, we're going to plug in -2, -1, 0, 1, and 2 for x. So these are the 5 different numbers I'm going to plug into that equation for x. If I plug in -2 for x, we're going to get 2 times -2 minus 1 equals y. Well, 2 times -2 becomes -4. -4 minus 1 becomes -5. So this number right here, in just a second you're going to see, is going to say -5. Then we're going to start all over, and instead of plugging in -2, we're now going to go through and we're going to plug in -1. So we would end up with y equals 2 times -1 minus 1, which would be -2 minus 1, or -3. Well, if you plug in 0, 0 is easy because it makes your x go away. 2 times 0 is just 0. So if we take that away, we get 0 minus 1, which is negative 1. And we're going to continue on plugging in 1, plugging in 2. Notice, when I plugged in negative 2 for x, we got a value of negative 5. When I plugged in negative 1 for x, we got a value of negative 3, and that gave us negative 1, negative 3. If I plug in 0, we got negative 1. If I plug in 1, 2 times 1 is 2, 2 minus 1 is 1. And if I plug in 2 for x, 2 times 2 becomes 4, 4 minus 1 is 3. So what we've done is we've generated a table of values, x values and their corresponding y values. The next thing you're going to want to do with that is to list them as ordered pairs. An x and a y, like I've circled up here, would give us the point negative 2, 5. This would give us the point negative 1, 3, 0, negative 1, 1, 1, and 2, 3. When we write those as ordered pairs, we can now go on a coordinate plane and graph those points. Notice, negative 5 means we go left 2 and down 5, and that gives us a point right there. Negative 1, negative 3 means we go left 1 and down 3. 0, negative 1 is just down 1 from the origin. 1, 1 means we go right 1 and up 1 from the origin. And 2, 3 means we go right 2 and up 3 from the origin. If you look, all of those dots, all those points, form a straight line. So we then take out our ruler. Yes, a ruler, because lines are supposed to be straight. And we're going to draw the line that connects all of those points. And remember, lines have to have arrows at both ends. Now, we've labeled 5 points on there. But what this line represents when we draw the line is every single solution that works. All of these points in between, that line is just made up of billions and billions and billions of points really close together. And the coordinates of all of those points would all be solutions to that equation. So we started by putting 5 points on there, but there are really billions of points. Anything on that line is a solution. Here are a couple of examples for you to do. Again, start with a table of values. My suggestion is to put the equation right in your table of values. Go ahead and hit pause and work on these, and we'll see how you do. Alright, so plugging in for x, we're going to again use negative 2, negative 1, 0, 1, and 2. If I plug in negative 2, I get y equals 2 times negative 2, which is negative 4. If I plug in negative 1, I get y equals negative 2. If I plug in 0, I get y equals 0. If I plug in 1, I get y equals 2. And if I plug in 2, I get y equals 4. I'm going to graph these points. That's negative 2, negative 4, negative 1, negative 2, 0, 0, 1, 2, and 2, 4. Again, keep in mind your first number, your x, tells you left or right. Your second number in your ordered pair, your y, tells you up and down. All of those are measured from the center of the graph, the origin. So negative 2, negative 4 means left 2, down 4. Negative 1, negative 2 is left 1, down 2. 0, 0 is right on the origin. 1, 2 is right 1 and up 2. 2, 4 is right 2 and up 4. You should see that they all form a line, so we're going to take out a ruler. We're going to draw the line that goes directly through all of those points. And we're going to put arrows at both ends. For the second one, it's a little bit more difficult because there's more to the equation than just an x, y equals 2x. So if I plug in negative 2, negative 1, 0, 1, and 2, this is where it's important to list my equation right in there. When I plug in negative 2, I get y equals the opposite of, or minus, negative 2 plus 3. Well, the opposite of negative 2 becomes positive 2. 2 plus 3 is 5. When I plug in negative 1, I get y equals the opposite of x, the opposite of negative 1, which becomes positive 1 plus 3, which is 4. If I plug in 0, I get y equals 0 plus 3, which is 3. Plug in 1, I get negative 1 plus 3, which is 2. And if I plug in 2, I get negative 2 plus 3, which is 1. Now my ordered pairs then would become negative 2, 5, so left 2, up 5. Negative 1, 4, left 1, up 4. 0, 3, 1, 2, 2, 1. And again, those points all seem to form a line. So we're going to draw that line right there. And we're going to put our arrows there as soon as I change it. Hopefully you did well on those. A couple more examples here if you'd like to work on them. We're going to pass on those for now. Horizontal and vertical lines are two special kinds of lines we need to talk about. When you have a graph or an equation y equals 3, notice we're talking about an equation of two variables, only this one only has one variable, y equals 3. What that means is graph all points when y equals negative 3, or excuse me, y equals positive 3. So let's list some of those points where y equals 3. We got the point 0, 3. We got the point 1, 3, and 2, 3, and 8, 3. I could put in negative 7, 3. Any point where our y coordinate, our second value, is 3. Well, let's look and see what some of those points look like. 0, 3 would be just up 3. 1, 3. 2, 3. 8, 3 is way out there. Negative 7, 3 is negative way out there. All of these points seem to fall along the same horizontal line. Could be 10, 3, 9, 3, 8, 3, 7, 3, 6, 3, 5, 3, 4, 3, 3, 3, 2, 3, 1, 3. Negatives. And if you look at all those points, they do fall along the same horizontal line. And that's how we graph that line. Y equals 3. It's every point where y value is 3. Notice it's a horizontal line that goes through our y-axis at 3. Looking at it the same way, if we want to talk about graphing the line x equals negative 2, well, that's every point where x equals negative 2. So that could be the point negative 2, 0, negative 2, 1, negative 2, 2, negative 2, 10, negative 2, negative 10, any point where our x coordinate is negative 2. And if we look at some of those points, that means we go left 2, but we don't go up and down. We go left 2 and up 1, left 2 up 2, left 2 up 10, left 2 down 10. It's any point where we go left 2 from the origin. And again, this would be an equation that's going to look like a vertical line instead of a horizontal line. It is every point where our x-coordinate is 2. Every point that is 2 spaces to the left of the origin. Notice this is a vertical line that goes through our x-axis at negative 2. And that's how we graph vertical and horizontal lines. Excuse me, horizontal and vertical lines. One last thing to talk about before we're done for the day. When we want to graph these functions, sometimes they're not written in what we call function form. And function form would be something that is solved for y, meaning that the y is on one side of the equation by itself. An example would be down here, y equals negative 3x plus 7. Notice that this is in function form because the y is on one side of the equal sign by itself, and the rest of the equation is on the other side. Not every equation is written in function form, however. If we look at one that's not, y, or 3x plus y equals 7, this is not in function form because the y is not on one side of the equation by itself. The y is added to a 3x on the same side of the equation. These equations that are not in function form, it's not easy all the time to come up with a table of values for them. In other words, it's not easy to graph them. What will make it easy is if we can change it from not function form into function form by getting the y on a side by itself. This makes it easier to plug in values for x and just get an answer for y. So if I'm going to get y by itself in this original form up here before it was in function form, all I'm going to do is use the same rules we learned last chapter on solving equations, and earlier this year as well. We want to get the y by itself, so I need to get rid of this 3x that was added to it. So I'm going to just subtract 3x on both sides of the equation. The 3x and the minus 3x on the left-hand side cancel out, and I'm left with just y equals. We have 7 minus 3x. Well, remember, 7 minus 3x means the same thing as 7 plus a negative 3x. 7 minus 3x would be acceptable, except that we always want to list our equations in the correct form, which would be from x, highest degree of x, down to lowest degree of x. In other words, we want to list our x's before we list our constant terms. So we're just going to use our commutative property to rewrite it as y equals negative 3x plus 7. From here, it's very easy to make a table of values. Notice if I plug in a number for x, it's going to be, y is going to equal negative 3 times x, which is negative 2. Negative 3 times negative 2 is positive 6, plus 7, which is 13. If I had to plug in negative 2 at the original up here, I would have 3 times negative 2 is negative 6. Then I would have to add 6 to both sides. And if I'm going to be plugging in 5 different numbers from x, that means I'm going to have to do that same step 5 different times. And it's just more time consuming. The typical question that you might find on your homework tonight or on a quiz or a test coming up is, write x plus 2y equals 6 in function form, then graph the equation. Well, if you want to write an equation in function form, remember that just means to get y by itself or solve for y. So in this case, I have x plus 2y equals 6. I need to get the y by itself, so I need to move the x to the other side. So I'm going to subtract that x over. That gives me 2y equals, I'm going to write the negative 6 in front of the positive, or the negative x in front of the positive 6, because that's the order I want to have it in. Also keep in mind, when I say negative x, that means the same thing as, oops, let me move this a little bit, that means negative 1x. Now notice we've got the y term by itself, but we don't have just a y, we have 2y. So to get rid of the 2, I need to go through and divide everything on both sides by 2. Each term gets divided by 2. When I do that, I'm left with y equals negative 1/2 x plus 6 over 2, which I'm going to reduce to 3. So what I've done is I've taken an equation that was not in function form and I've put it in function form. Now we want to make a table of values that we can use to graph that equation. Well, notice if I plug in any odd number in this case, 1 or 3 or 5, when I plug in 1, I'm going to get negative 1/2 plus 3. Well, that's going to be negative or positive 2.5, and that's going to be a tough number to graph. So when I plug in numbers where my x is multiplied by a fraction, like we have here, I always want to use numbers that are a multiple of the denominator. And the reason is it's going to cause all the fractions to go away. I won't have to worry about fractions in my y values. So for example, when I make a table of values here, I'm going to use numbers that are a multiple of 2, like -2, 0, 2, and 4. Do I have to? No, but it's going to make the numbers I deal with a lot easier. So if I plug in -2, I'm going to end up with y equals -1/2 x plus 3, which in this case would be -1/2 times -2. Notice, -1/2 times -2 over 1. The 2's cancel out. So I have a negative times a negative, which becomes a positive. My 2's cancel out, and I'm just left with a positive 1. When I plug in 0, y is going to equal -1/2 times 0. Well, anything times 0 is 0, plus 3 is 3. If I plug in 2, let me go back up here and work that out again. That's going to tell me y equals -1/2 times 2 over 1. Then the 2's are going to cancel out and leave me with -1 times 1, which is -1. Oops. Plus 3, -1 plus 3 becomes 2. And I made a mistake earlier. Let me go backtrack. When I plugged in -2, yes, y is 1, but I forgot to add the 3, which gives me a 4. So that first one should have been 4. I apologize. When I plug in 4, I'm going to end up with y equals -1/2 times 4 over 1. Well, the 2 and the 4 reduce. I'm left with -1 times 2, which is 2. And then don't forget that I've got to add 3, like I did the first time. -1 times 2 is -2. -2 plus 3 becomes y equals 1. Now we've got the ordered pairs -2, 4, 0, 3, 2, 2, 4, 1. And they are on a straight line, so we take out our ruler and we connect that line. And we make sure we draw arrows at both of them. Oh, that's not supposed to happen. And we make sure that we put arrows at both ends. Here's your homework from this section. We will go over this, and again, I will answer any questions you've had from this section or the last section due to my absence. When I return, I should be back at school on Thursday.